We're looking at velocity time graphs and acceleration today, and we're going to start by looking at the movement of a car to help us to understand. Now, let's imagine we've got a car sitting there doing nothing for a moment, and then off it goes, starts to accelerate, hits a steady speed for a while, accelerates further, and then suddenly slows down. Just like in the distance time graph, we can show this using some data on a table. So let's have a look at that. So we've got time versus velocity, and it's important to mention here that velocity is how fast something is going in a particular direction. This is sometimes mixed up with the word speed, and generally it means the same thing. The only difference is that velocity involves giving a direction. Okay, so velocity has direction, speed, you don't mention a direction. So here we have the table, we've got time along the top and velocity along the bottom, and you can see changes in the movement of the car. So at time 0 it's not moving, after 5 seconds it goes up to 10 meters per second. Remember, the unit for velocity is meters per second, and so on over time, and you can see what's going on there. Now, the first thing I want to do with this data is to calculate the acceleration, and in terms of acceleration, that means speeding up. It also can mean slowing down, that's when you've got a negative acceleration, but for the moment let's just say it means speeding up, and the formula for working it out is this. Okay, so acceleration is the final velocity, take away the initial velocity over the time taken. So the acceleration, the unit, is in meters per second per second. Velocity is meters per second, same for both of these, and time is in seconds. Now, this formula is actually given to you in the exam. It'll be on the formula sheet, but it's written like this. It's written as A equals V minus U divided by T, and that actually means exactly the same thing as this. And in the exam they also do tell you what the different letters mean, so it shouldn't be a huge problem to use it. The only thing they don't tell you is the units for each one, so you must make sure you remember those. So let's have a look at an example. So we could say, let's work out the acceleration for this part of the table here. So the final velocity here is 20, so we can put that in there. That's the final velocity, meaning the velocity at the end of this little section we're looking at. The initial velocity, that's the start velocity, well that's 10, so that's minus 10. And the time taken to do that goes from 10 to 20. Don't just read off that number there and say it's 20 seconds, it's the time taken to go from here to here. So from 10 seconds to 20 seconds, that's a period of 10 seconds. It took 10 seconds to do that. So that would then become 10 over 10 equals 1. And to get the unit correct, you have to say meters per second per second. In actual fact, another way of writing that is meters per second squared. So there's your answer. That's how you work out acceleration from data on a graph. I'm going to give you one more example. This is a slightly wordier question, and you can imagine that you might get something like this in the exam. So how would we work this out? Well, we've got a car goes from rest to 30 meters per second over 5 seconds. Calculate this acceleration and give the correct units. So you might want to give this a go now and see what the answer is in a moment. So you can pause and look at the answer, or you can just carry on watching. But the answer goes like this. So for this part here, let's call this question 1. So for question 1, we've got a car going from rest to 30 meters per second. So first thing, if we write the formula, acceleration equals V minus U over T. Remember, this is given in the exam. And the final velocity here is, well, it's going from rest to 30 meters per second. So the final velocity is 30. Take away the initial velocity from rest, that means from not moving, so that's 0 meters per second. So it's 30 minus 0 divided by the time taken, and the time taken in this case, it tells you over here, it's 5 seconds. So the answer is 30 over 5, which is 6 meters per second squared. Don't get the unit wrong. So students often make a mistake with that, so it's important that you get that right. And for the second part, again, if you want to work it out for yourself and check the answer, you can. So you can pause now, but I'll go through it just to make sure you understand. So we've got the car then stops at traffic lights over 2 seconds. So again, using the same formula, in this case the car stops, so the stopping is the final velocity, so it's 0 minus, and the initial velocity was when it reached 30 in the first part of the question. So it's 0 minus 30 and tells you it's 2 seconds. So be careful here, because in this case 0 minus 30 is minus 30 divided by 2 is minus 15 meters per second squared. Okay, and this just illustrates the point that if you've got a minus acceleration and negative acceleration, that's the same as slowing down. Okay, and you show that with a little minus sign. Okay, so that's how you calculate your acceleration. The next thing I want to go through is looking at what the different parts of a velocity time graph means. So here we go, we've got the table from the first page up here, and down here I've drawn out the graph, so you can see the points plotted out, and all you would do then is just to join the lines up. Okay, and then you have your graph. Now it's very important that you are able to say what is going on in the different parts of the graph. So this is, let's call this part A, B, C, D and E, and it's different compared to a distance time graph. These lines mean different things compared to a distance time graph, and it's very important you don't get those wrong. So for part A, the line is going upwards. On a distance time graph, that means going at a steady speed. But this is a velocity time graph, and you can see that as time goes on, the velocity is increasing. So here we say we have steady acceleration. Okay, so part B is steady acceleration. Sorry, part A is steady acceleration. If you look at part B, there is no change in the velocity, so we say steady velocity. So the velocity stays the same, it's going at a steady speed or velocity. And for part C, you can see it's accelerating again. It's accelerating again, but if you compare that to part A, the line is steeper, so it's got a greater acceleration. It's got a greater acceleration than we have at part A. Again, we're going at a steady velocity for a while. The steady velocity is much higher, so before it was going at 20 meters per second, here it's going at 40 meters per second. And then in the last part of the graph here, the velocity decreases, so we say we have deceleration. Or you can also say negative acceleration, or you can also say slowing down. Okay, so these are what the different parts of a velocity time graph mean. Remember to not get this mixed up with the different parts of a distance time graph, because they do mean very different things, and I will make another video comparing the two, and just so that you don't get those wrong in an exam. I'm going to stop there. The next video is going to be about the higher tier and calculating acceleration from velocity time graphs, but for now that's me done.